All right, let's dive in. Today, we are talking about one of the coolest fields you can possibly get into, mechatronics and robotics. We're basically going to build you a roadmap, a step-by-step guide so you can figure out how to build a career creating the smart machines of the future. So, let's get right to it. So, you're into robots, right? I mean, who isn't? You see them in factories and hospitals, heck, even zipping around on other planets, and you're probably thinking, man, I want to build that. But then comes the big question. Where do you even start? It can feel kind of confusing. Do I need a degree, a diploma? What's the real difference anyway? Well, that's probably the number one question we get, and today we're going to break it all down.
You know, the easiest way to look at this is like a journey with three main paths, or maybe levels. Each level builds on the one before it, opening up totally new doors and possibilities. So we're going to map out every single one of these paths for you. That way, you can see exactly where you might fit in.
Okay, let's start at the beginning. Level 1, the diploma. Think about it like this. If your career is a building, the diploma is the absolute foundation and the structural framework. It's that crucial first step where you really get your hands dirty and learn the guts of how machines actually work. This level, it's all about practical, hands-on skills. You're learning mechanics, which is like the skeleton of a machine. Then you've got electronics. That's the nervous system. You'll get into pneumatics and hydraulics, basically the muscle, and you'll start dipping your toes into programming with things like Arduino and PLCs. Oh, PLC, that just stands for Programmable Logic Controller. It's the brain behind almost all the automation you see out in the world. This is a super solid, practical foundation. And you learn all this stuff step by step. I mean, you're not just going to read about circuits in a textbook, you're actually going to build them. You won't just sit around talking about robots, you'll build them from kits. From there, you'll move on to small automation projects, and you'll even do industrial visits so you can see with your own eyes how these skills are used in the real world. So at the end of the day, a diploma points you in two really clear directions. Option 1, you can jump straight into the workforce as a skilled technician. You'd be the person on the ground, installing, maintaining, and fixing robotic systems. Option 2, you can use it as the perfect launch pad to climb up to level 2. And that brings us right to level 2, the bachelor's degree. Okay, so if the diploma built the foundation and the frame, the bachelor's is where you come in and install all the advanced stuff, the core systems. This is where you add the real intelligence, the sophisticated sensors, and the complex software that makes a robot, well, truly smart. And believe me, the curriculum takes a huge leap forward here. We're talking about mastering advanced robotics and control theory. That's the science behind making robots move with incredible precision. You'll be designing complex parts using software like SolidWorks, and you'll learn really powerful industry tools like MATLAB and ROS, which is the robot operating system. This is also where you start bringing in the big guns, like AI and the industrial Internet of Things, to create these complex, connected, intelligent machines. The hands-on work gets a major upgrade too. You're moving way beyond basic kits. Now you're designing and prototyping your own unique robots from scratch. The whole focus shifts to real-world applications, so things like internships and live industrial projects become a central part of your education. You'll be tackling actual engineering problems for real companies. Once you have a bachelor's degree, you're looking at engineer-level jobs. See the difference? You're not just maintaining the systems anymore, you're the one designing them. You could work in R&D, helping create the next generation of tech. And of course, this degree sets you up perfectly if you decide you want to go for the highest level of specialization.
So just how big is that jump to a master's? Well, let's take AI as an example. In a bachelor's program, you learn the basics of AI. But in a master's, oh, you go deep, really deep. You're not just using AI anymore, you're mastering advanced stuff like computer vision, literally teaching a robot how to see and understand what it's seeing, and machine learning. I love this analogy. It's the difference between knowing how to drive a car and knowing how to design the engine.
And that, of course, brings us to level 3, the master's degree. Look, this level isn't just about learning what's happening right now. It's about defining what comes next. This is the path for the real innovators, the researchers, the people who want to lead the entire field into the future. The skills you learn here are on the absolute cutting edge of technology. You're diving deep into super specialized fields like advanced AI and high-precision control systems. You'll work with mind-bending concepts like digital twin technology, where you create a perfect virtual copy of a physical system so you can test and innovate on it without breaking the real thing. It's wild. You're not just learning tech anymore. You're learning how to do research and how to manage the process of innovation itself.
And at this level, your work starts to have a serious, real-world impact. We're talking about developing fully functional robotic systems that solve incredibly complex problems. You'll find yourself collaborating with top-tier research labs, and your end goal might be to publish your work in technical papers or even file for patents. You're not just a student anymore. You're actively contributing new knowledge to the world.
The career paths that open up from here are, frankly, top tier. You're looking at leadership roles, becoming a highly sought-after specialist in R&D, or maybe working as an automation consultant, the expert who advises entire industries on what to do. And of course, this is the main path if you want to have a career in academia, researching and shaping the minds of the next generation of engineers.
Okay, so, wow, we've gone through all 3 levels of this journey. So now, let's pull it all together. Let's look at a single map so you can really start to picture your own course forward.
All right, let's break it down one last time, nice and simple. The diploma, that's your hands-on foundation setting you up for technician roles or further study. The bachelor's, that's your ticket to being an engineer, focusing on design and applied innovation. And the master's, that's for deep specialization, research, and leadership roles. 3 distinct paths, and every single one leads to a powerful career. So if all of this has got you fired up and you're ready to figure out your next step, one of the best things you can do is connect with people who are already on this path. The Mechatronics Forum is an amazing online community. You can go there to ask questions, bounce ideas around, and find a ton of other resources. Seriously, don't try to figure this all out alone. Go join the conversation.
So there you have it. We've laid out the entire roadmap, all the way from the foundation to true innovation. The paths are clear, and the opportunities are they're incredible. So really, there's only one question left, and it's the most exciting one. You've seen the map. Now, what are you going to build?